Good morning again. So today we will deal with the next topic, that is wire-based additive manufacturing, especially fused deposition modeling. So in the previous videos, we have learned about the basic ideas about the 3D printing technology, its geometry capability, material capabilities. Then after that, the STL file preparation, STL file manipulation, the details about the STL files triangles, its two formats such as ASCII format and binary format. Then after that, we discussed about the different types of uh, solid modeling techniques such as constructive solid geometry, feature based solid modeling, boundary representation, some hybrid approaches, so and so. Then we have learned about the different types of slicing such as uniform slicing, adaptive slicing, direct slicing, indirect slicing, horizontal slicing, conformal slicing, etc. So today we will deal with the fused deposition technology or fused deposition 3D printing. Okay, so we are starting the today's topic, that is fused deposition technology. So this is basically related to the wire-based additive manufacturing. First, we will explain the wire-based additive manufacturing. Then we will enter into the fused deposition modeling technology. So wire-based additive manufacturing or wire additive manufacturing is a process whereby materials are added layer by layer to form a three-dimensional object. This process involves the use of materials such as polymers, composites, wax, or metals, which are fed into the machine in the form of wire, as shown in the figure. The material flow can be either continuous or on demand, which means that the material is either fed continuously or in small drops as required. The machine kinematics used in wire additive manufacturing can be serial, parallel, or a hybrid of both. In serial kinematics, the additive manufacturing process is carried out in a linear fashion, with the wire being fed into the machine from one end and the finished product emerging from the other end. In parallel kinematics, the process is carried out in a more complex manner, with the wire being fed into the machine from multiple angles and the finished product being built up from multiple layers. The energy sources used in wire additive manufacturing include resistance heating, induction heating, arc melting, or energy beams such as laser or electron beams. Resistance heating involves passing an electric current through the wire, which heats up and melts the material as it is fed into the machine. Induction heating involves using a magnetic field to heat up the wire, while arc melting involves using an electric arc to melt the wire. Energy beams such as laser or electron beams use a concentrated beam of energy to melt the wire and form the finished product. Overall, wire additive manufacturing is a versatile and flexible process that can be used to create a wide range of objects, from simple shapes to complex geometries. The choice of material, machine kinematics, and energy source depends on the specific requirements of the project and the desired outcome. Then we will enter into the details of a company named Stratasys. So Stratasys is a renowned and innovative manufacturer of a cutting-edge 3D printing technology. The company offers a wide range of products and services, including 3D printers, software, and materials for polymer additive manufacture. Stratasys also provides on-demand 3D printed parts, making it a one-stop shop for all 3D printing needs. Founded in Israel in 1989, Stratasys has grown into a global company with a presence in the United States and around the world. The company has enjoyed significant success in the 3D printing market thanks to its commitment to quality, innovation, and customer satisfaction. Stratasys 3D printers are designed to handle a variety of applications from rapid prototyping to production grade manufacturing. The company's software solutions enable users to design, simulate, and optimize their 3D models, while its materials portfolio includes a range of thermoplastics, photopolymers, and other materials to suit different applications. In addition to its hardware, software, and material offerings, Stratasys also provides a range of support services, including training, consulting, and technical support. With its comprehensive suite of products and services, Stratasys is a leader in the fast-growing and dynamic world of 3D printing. Then we will enter into the fused deposition modeling. So fused deposition modeling is a widely used 3D printing technique that involves a few important steps. The process starts with pre-processing, which is the first step. In this step, a computer-aided design CAD model is created, and then it is converted into an STL format, that is standard tessellation language. The STL file is then oriented and support structures are generated. This is done to ensure that the final product is stable and has a proper structure. The model is then sliced into layers and the area is filled. Finally, G-codes, which are instructions for the 3D printer, are generated. The second step in FDM is building the part. This step involves depositing buffer layers, which are used to ensure that the part adheres to the build plate. After that, the main material is deposited layer by layer. In the figure, you can see the two different materials, such as support material spool and model material spool. So this is our main material, and this color represents the support material. So during the building process, depositing buffer layers, which are used to ensure that the part adheres to the build plate. After that, the main material is deposited layer by layer. So this green color is representing the main material. This process continues until the part is complete. Depending on the complexity of the part, support material may also be deposited. So this orange color is representing the support material. This is done to ensure that overhangs and other complex features are properly supported during the printing process. And the final step, the third and final step, is called post-processing. This step involves removing the support structures from our final product. This can be done manually or with the help of a support removal system. Once the support structures are removed, once the support structures are removed, the surface of the part is finished. This can be done with sanding, polishing, or other techniques to achieve the desired surface finish. In overall, fused deposition modeling is a sophisticated 3D printing technique that involves several important steps. By following each step carefully, one can produce high-quality parts with a wide range of applications. Then, coming to the machine architecture. In fused deposition modeling, FDM 3D printing, the feedstock. So this is called the feedstock. That is the material. This is the feedstock. The feedstock used is typically an amorphous thermoplastic polymer filament, which typically has a diameter of 1.5 to 3 mm. In smaller scale systems, the feedstock is simply a loose coil, while larger manufacturing systems use a cartridge to supply the system. The filament is pushed through a pinch roller mechanism. So I will show you another figure. Yeah, here you can see two rollers. So this is called a pinch roller. So this is the filament. The central portion is representing the filament. This green color is representing the filament, and the filament is pushed through a pinch roller mechanism, which is connected to a stepper motor. The stepper motor provides the energy to move the filament through the system. The rollers are made of hypolon or polyurethane, and one or both of them have a grooved or toothed surface to create sufficient friction to grab the filament and feed it into the liquefier without slippage. So this is our liquefier. The pressure on the filament between the rollers is typically enough to slightly deform the filament, leaving small tooth marks so as to avoid crushing the filament. This is important because if the filament is crushed, it can cause inconsistent extrusion, which can result in a poor quality print. Overall, the pinch roller mechanism is an essential component of FDM 3D printing, as it ensures that the filament is fed smoothly into the system, allowing for consistent and high quality prints. So next I will show you an animation video from Stratasys. So this video will give you a very good idea about FDM. It's a very good video about that the working of FDM technology. Yeah. So in the figure, you can see the left white color. This represents the support material. So this is the support material, and this is called the pinch roller mechanism. And on the right side, the black color is representing the build material. So the filament. So the white color is the support material, and the black color is the builder material. And these two material or these two filaments are pushed through a pinch roller mechanism. So this is the pinch roller mechanism, and this is connected to a stepper motor. And the stepper motor provides the energy to move the filament through the system. The rollers are made of hypalon or polyurethane, and one or both of them have a grooved or toothed surface to create sufficient friction to grab the filament and feed it into the liquefier without slippage. The pressure on the filament between the rollers is typically enough to slightly deform the filament, leaving small tooth marks so as to avoid crushing the filament. This is important. If the filament is crushed between these two rollers, it can cause inconsistent extrusion, which can result in a poor quality print. So this is our final 3D printed part, whereas the black represents our final part and the white represents the support structure. And finally, during the post-processing operation, we have to remove the support structure. Yes. So the important components in FDM are the liquefier. So this is a very important component, and another one is the pinch roller mechanism. This is the pinch roller mechanism. So the pinch roller mechanism is a critical component in FDM FDM 3D printing process that assist in feeding the material into the liquefier. So this is the critical component that is allowing the material into the liquefier. The material is placed above the pinch roller where it experiences tension, while below the roller it experiences compression. So here above the pinch roller tension and below the pinch roller it experiences compression. So this mechanism ensures a constant and uninterrupted supply of material to the nozzle. To understand the pinch roller mechanism's function, it is essential to know how it works. The pinch roller is responsible for guiding the filament into the liquefier where it is melted and finally extruded. The filament moves through the pinch roller and into the liquefier through a small orifice. The angular velocity of this pinch roller plays a crucial role in determining the filament's feed rate into the liquefier. The velocity can be calculated using the formula. Proper calculation of the angular velocity ensures that the filament is fed at the appropriate rate, ensuring optimal printing conditions. Overall, the pinch roller mechanism is a very critical component in FDM 3D printing that ensures a consistent and uninterrupted supply of material into the liquefier, resulting in high quality prints. Next, I will explain the details of an FDM 3D printer, that is Ultimaker S5. So this is the Ultimaker S5 3D printing machine. So we will enter into the details of the specifications, specs. The Ultimaker S5 3D printer is a state-of-the-art machine that boasts an impressive range of features. Its build volume, you can see the build volume. Its build volume measures 330 by 240 by 300 mm, providing ample space for even the most complex design. So the maximum height we can print is 300 millimeter. That means 300 millimeter. That means 30 centimeter. When fully assembled, the fully assembled dimensions, the printer's dimensions are 495 by 585 by 780 mm. So the total height of the printer is 780 millimeter. That means 78 centimeter. 78 centimeter is the total height of this printer. The Ultimaker S5 utilizes fused deposition modeling. So we already explained the technology. The print technology using is fused deposition modeling and is compatible with filament diameters of 2.85 millimeter. So the filament diameter here is using is 2.85 millimeter. The weight of this machine is 29.1 kilogram and has a maximum power output of 500 watt. In terms of the printer properties, the Ultimaker S5 offers stunning detail with its layer resolution, which varies depending on the nozzle size. The 0.25 mm nozzle provides a resolution of 150 to 60 micron, while the 0.4 mm nozzle offers 200 to 20 micron. The 0.6 mm nozzle offers 300 to 20 micron, while the 0.8 mm nozzle offers 600 to 20 mm micron. The XYZ resolution is equally impressive, measuring at 6.9, 6.9, 2.5 micron. The printer also features a dual geared feeder reinforced for composite materials and a 4.7-inch color touchscreen display. Additionally, the printer's print cores are swappable, allowing for easy replacement. The Ultimaker's S5's print head is a dual extrusion system with an auto nozzle lifting system, which ensures accurate printing even with complex designs. The printer features 4 nozzle diameters: 0.25 mm, 0.4 mm, 0.6 mm, and 0.8 mm. Coming to the operation parameters, the Ultimaker S5 operates within a temperature range of 15 to 32 degrees Celsius and produces an operating sound of less than 51 dBA. The printer's advanced active leveling build plate ensures precision and accuracy, and the glass build plate heats up in less than 5 minutes. The printer's nozzle temperature ranges from 180 to 280 degrees Celsius and has a heat up time of less than 2 minutes. The non-operating temperature range is 0 to 32 degree Celsius. So I am concluding this video. Okay, so we are concluding our video. So the video we watched provided an in-depth understanding of wire additive manufacturing with a focus of fused deposition modeling, FDM. We also delved into Stratasys, a leading company in this field, and the different product it offers. Furthermore, we explored the various stages involved in the FDM 3D printing, such as pre-processing, building and post-processing, including the machine architecture with the details of liquefier and the pinch roller mechanism. Specifically, we discussed the details of the liquefier, which melts the material, and the pinch roller, which feeds the wire through the machine. In addition, we watched an informative animation video from Stratasys that demonstrated the working of FDM, providing a clear understanding of the process. Finally, we provided a detailed information about the Ultimaker S5 FDM 3D printer, its features, and how it works. Thank you.